Now on this page you can see a computer generated direction field for the differential equation we looked at in the previous example. Remember we had dy dx equals x squared minus y. And when you look at this picture here, we can now start to figure out what solutions look like with a given initial condition. So if you look at this solution right here that was drawn, when you start here, the slope of this solution, the blue line, is very close to the slope of this direction marker. Similarly, in this point, slope of the solution is near identical to the slope of the direction marker. Same here, and here again. And so you can do this for several initial values. So you could start here, you could start here, you could start here, etc., etc. So now let's consider the differential equation dy dx equals negative 2y. So this is a differential equation where the function on the right hand side, f of xy, is equal to negative 2y. So the value of that function does not depend on x. And you can see that in the direction field here. So all these points with the same y coordinate have the same slope for their direction marker. And similarly here, you see it doesn't matter what my x is. If my y is constant, then all these slopes are constant. So now we're going to draw several solutions to this equation in the direction field below, and then we're going to ask what do they have in common. So if for instance we start about here, we see that the slope of the direction marker has negative slope, so our solution is going down. And then here it's going down as well, but a little less steep. And so then we might show up here and we're still going down, but ever so less steep. And so we're going to approximate the x-axis. And similarly, if we start at the bottom, we start off pretty steep, and then once we get to a less negative y value, our solution gets less and less steep, but will also approximate the x-axis. And if we actually start on the x-axis, the direction markers have slope 0, and so we stay on the x-axis. We stay constant. Now, my skills on the tablet are not as good, so I'm going to cheat a little bit here. I'm going to import something that I did by hand. So I'm going to add an image, and I'm going to put it over here. Scale that down just a little bit. And so what we see here is an approximate solution, or 3 approximate solutions. Now, what do they all have in common? They all approach the x-axis. So what we can write down here for the solution is that limit as x goes to infinity of y of x, our solution to the differential equation, is 0. Or stated differently in terms of algebra, the horizontal asymptote is y equals 0. Now let's look at another differential equation where dy dx equals negative y over x. And so our differential equation is f of xy equals negative y over x. And here are the corresponding direction markers. So if we start somewhere in quadrant 2, so over here maybe, we slightly increase. And then when we move over to the right, we see that the slope is increasing. And then slope is increasing. And now what appears to happen is that we're approaching the y-axis. So if we start here, we have that kind of solution. Now here in the first quadrant, if we start over here, we decrease very rapidly in the beginning, but then it starts to level off and our solution is approaching the x-axis. And similarly, if we start in quadrant 3, we decrease slowly at first, but then we start to decrease more rapidly, and then we start to approximate the y-axis or approach the y-axis. And in quadrant 4, you start here, you increase rapidly first, then less steep, and we start to approach the x-axis. And again, I'm going to cheat a little bit here, and I'm going to add the solution that I did by hand on a piece of paper, and we'll put that over here. As the solution. So again here, if we start on the x-axis, so what do we know about the x-axis? We know that at the x-axis y equals 0. So if we plug in y equals 0, we see dy dx equals 0. So all the direction markers have slope 0, and that means that we have a constant solution, y equals 0. And then the other thing that we see is that for this function, we approach the y-axis, but we never seem to cross it. And so aside from this special solution, we see that all solutions are confined to one quadrant, and if we're on the left side of the y-axis, we approach the y-axis. If we go forward in time, if we follow our solution, and here if we go backward in time, we approach the y-axis. So if we write down the answer to this question, what do they have in common? We can say they are all confined to one quadrant. And that's except for the special solution y equals 0. And can a solution cross the x-axis? The answer is no, except when we have the special solution y equals 0.